Vocabulary for Chapter 3. Domain. Set of x coordinates at the ordered pairs of a relation. Negative correlation. If one set of data values increases as another set of data values decreases, the relationship can be described as negative correlation. Term. Each number in a sequence. Arithmetic sequence. A sequence made by adding some value each time. Difference. The difference between each number in an arithmetic sequence. Continuous graph. Graph made up of connected lines or curves. Correlation. Relationship between two data sets. Dependent variable are the y values. Discrete graph. Graph made up of distinct points. Function. A relation of each element of a given set, domain, is associated with an element of another set, which is the range. Function notation. F of x. Function rule. Algebraic expression that defines a function. Independent variable are the x values. No correlation. No relationship between data sets. Positive correlation. Increased data value. Range. Second coordinates. The y. Relation. Relationships can be represented by a set of ordered pairs. Scatter plot. Graph with points plotted to show a possible relationship between two sets of data. Sequence. List of numbers that often forms the path. Trend line. Line in a scatter plot that helps show correlation between data sets more clearly. This is section 3.1. It says sketch a graph for each situation. Tell whether the graph is continuous or discrete. For example, a parking meter has a limit of 1 hour. The cost is $0.25 per 15 minutes and the meter accepts quarters only. So first what you're going to do is you're going to make a graph of quarters in time, which is minutes, and you're going to plot the points on the graph, and it's like a discrete graph because only quarters are accepted, the points are not connected. So it's not in a line like a continuous graph would be. Another example of 3.1 is Ian bought a cup of coffee. At first, he slipped slowly. As it cooled, he drank more quickly. The last bit was cold and he dumped it out. So it's a graph with time and the amount of coffee in a cup, but this graph is not discrete. It's continuous because he sipped slowly, drank more quickly, and then dumped it out. So it starts from being up to down. In 3.1, they also might ask you to write your own explanation of a graph that they give you. So this first one is discrete, and you could say the temperature started off really high in the morning, then as the afternoon came, it got lower, and as it was nighttime, it got really cold. And then for the second one is continuous, and you could say the ball dropped from a second story all the way down to the ground. For section 3.4, you're going to graph the functions given a limited domain. So you're going to solve for y, and then you're going to plug in the domain, and you're going to solve, and you're going to get the x and y intercepts, and then you're going to graph. Also in 3.4, it says graph functions given a domain for all real numbers. So again, you're just going to find the x and y intercepts, and you're going to graph them. Unlike the other graph, this graph will be in a line, not points.
Expect to see a relationship between each ordered pair. Number of seats in a classroom and the number of students seated in the classroom. You would expect to see a negative correlation as the number of students increases as the number of seats decreases. The number of pets a person owns and the number of books a person reads a year. You would expect to see no correlation. The number of pets a person owns has nothing to do with how many books they read per year. Example 4. Matching a scatter plot to situations. Choose a scatter plot that best represents the relationship between the number of days and the sunflower seeds and the height of the plant. Explain. Example 5. Fundraising application. Scatter plot shows the relationship between the total amount of money collected and the total amount of rolls of wrapping paper sold at a school fundraiser. Based on this relationship, predict how much money will be collected when 175 rolls have been sold. Chapter 3, Section 3. Step 1. List all possible relationships between x and y. Step 2. Determine if one relationship works for the remaining values. Step 3. Write an equation. Example 2. Step 1. Identify independent and dependent variables in each situation. Example 3. Writing functions. Step 1. Identify the independent and dependent variables for each situation. Step 2. Write an equation notation for each situation. F of x equals 100x. Example 4. Evaluating functions. For f of x equals 5x, f of 6 equals 5, 6 equals 30. Substitute 6 for x and f of x equals x. Example 5. Finding the reasonable domain range of a function.